Good afternoon, everyone. My name is Julie Hansen. As an executive advisor here at Salesforce, it is my pleasure to welcome you to the Fortune CEO series, How AI is Transforming the Future of Business. In a few minutes, you're going to hear some insightful points of view from our panel. It's a very diverse panel. I hope you find it really enjoyable. But first of all, I would like to personally thank my co-host, Shirley Wright. She is the Director of Marketing in Canada. She just went through surgery a few days ago and has persevered to be here. So she has a lovely purple cast. We could not find her Salesforce blue. Now, Shirley, I was kind of wondering, when you got that cast put on, is that one of those new connected casts that measures all the heat in your arm so it can tell how fast you're healing and what kind of physio you should have?
Unfortunately, Julie, this is just a plain old school cast. There's nothing fancy about it. But that's a really good idea, though. Using IoT data and predictive insights. Does Einstein do that?
I think Richard Socher's in the house, and he's our chief scientist, so I think we should ask him later, because, you know, if I think of a really good use for healthcare, or for AI and artificial intelligence and Einstein, it's going to be in healthcare. And speaking of healthcare, I think our first guest today is from healthcare. So who do you have coming out to see you?
You bet they are. So Easter Seals Bay Area provides behavioral and health services and is at the forefront of care for people with autism. And autism is one of the fastest growing developmental disorders in the world today, and the prevalence of ASD has doubled over the last 10 years. I have with me here Susan Armiger, CEO of Easter Seals Bay Area, to discuss how ESBA is transforming the way that services are provided to meet this growing need for care. Susan, ESBA has served 125 clients in 2012, but today you guys are serving 3,500, more than 3,500 clients. And with over 300 new referrals coming in each and every month, how has this growth impacted your ability to service everyone that is in need of care?
That's a great question. It has really changed the way we have done business, because we were delivering those services ourselves, and we did some data analysis a couple of days ago, and we've had 21,000 referrals since 2012. So we had to grow and scale, and we had to develop a network that would actually support the needs of the families that were coming to this service line.
So you're really on a mission to transform the way that care is being provided, and technology appears to be a major contributor and factor in all of this. Describe an example of how this is happening.
Yes, it was really important early on that we understood how we could scale and be agile, and Salesforce became a really important choice early on. We were using Excel spreadsheets, and if you can imagine that with 21,000 people, even with the first 1,000, it was crazy. So we now have a whole client care cycle that is based on a platform. We had to really just create business architecture that met the needs of what we were doing.
That's amazing to hear. And, you know, how many cells would that be when you start adding up all those different Excel spreadsheets? And last question, Susan, on the topic today, how do you envision artificial intelligence helping you and ESBA's mission of providing the best care for families and individuals with autism?
Yeah, that's a very exciting question for me, because basically we can scale the technology to meet the needs, but what we're really trying to do is work out how to deliver effective care that impacts people's lives. And there's information around the world on this, and AI can come together and help us refine those care paths and really deliver treatment that makes sense for people.
That's amazing. And thank you, Susan, for sharing your story with us. It's great to see that technology is allowing you to make better and more impactful outcomes for those living with autism. Thank you for joining us.
You know, there's a lot of focus and hype related to AI, machine learning, deep learning, neural networks. And along with that hype, there's a lot of concepts and conversation around the data that's absolutely necessary to make any of the AI work and be effective. Nobody knows more about data than my next guest. I have Anil Chakravarthy, CEO of Informatica, the world's #1 provider of enterprise cloud data management solutions. And Neil, you've been working with data and related concepts before data scientists was ever coined as a term. You go way back in your knowledge and expertise. I was reading some of your articles. In one of your recent blogs, you actually discussed the hype around machine learning and AI, and you say that there is a true disruptive hype in one area, specifically to the data. So what is that disruption?
Yeah, absolutely. Thanks for having me here. In terms of data, when you look at what's going on right now, you have multiple trends coming together at the same time. You have, for example, data in the cloud, which is going to grow by 10x over the next couple of years. You have the number of business users. That's again doubled in just the last couple of years. You have the use of machine learning and AI for data. You have the variety of different data types that you have all of, mobile, social, IoT. And when you put all these trends together, just one of them would be sufficient to make a big impact. That's the disruption. That's the genuine disruption. We call it Data 3.0. That huge disruption in the world of data.
So what are some of the most impactful uses of AI that you've seen or come across in recent years? I think a lot of people are here just wanting to understand some of the business cases and hearing some of the detail that makes sense of the output of AI.
Yeah, AI started to, in the most recent generation of AI, a lot of consumer use cases of AI. If you think of, for example, what Amazon did with the recommendation engine. If you're looking for a book X, people who look for book X also like books Y and Z. What we are seeing now is really innovative uses of AI, similar uses in the world of enterprise. So for example, just to connect to the data conversation, you now have AI being used to help people find data within their own companies. You're looking for health data, for example, patient data, clinical data. It may be called anything, but AI helps you find the data you need for your business. And that's some of the most interesting things we have seen.
I could talk to you for another hour, but we have to carry on. I really want to thank you for just sharing a couple points with me. Anil Chakravarthy from Informatica, thank you so much for being here.
Thank you, Julie. Appreciate it.
Today, there are more than 16 million children growing up in poverty in the U.S. Children in extreme poverty are half as likely to graduate from high school and 1/10 as likely to graduate from college as students from more affluent communities. Teach for America, a nonprofit organization, is committed to giving all students access to an excellent education. With me now is Jessica Crowley, Managing Director of Business Analysis at Teach for America. Jessica, Teach for America is putting more teachers in the classroom in underserved areas. What are the key elements of this program?
Sure. So Teach for America is working to find, develop, and support a diverse network of leaders who are working to expand educational opportunity, both from within classrooms and schools, as well as across all sectors of society. So we train and offer ongoing professional development to our core members, which is what we call our teachers, and really position them to make dramatic academic and personal growth with their students. We also work to foster both the individual and collective leadership of our alumni, many of whom choose to stay in education after their 2-year commitment to teaching, and others go on to work in a variety of careers, whether it be policy or advocacy or law. But each person's path matters because together they form an incredible network of committed leaders who are working to expand educational opportunity in our country.
And this school year, in fact, you have over 6,000 core members, I've got the vernacular right, teaching in the classroom across 36 states, and that means over 400,000 students are being reached. What are 1 or 2 stories that you can share where you personally have witnessed this program changing lives for the better?
Sure. So there are so many incredible stories that I could share, but I think one thing that's particularly exciting to me in this moment is that we're starting to see what that change can look like, not just in an individual classroom or school, but what it can look like at a system-wide level. So if you look at New Orleans, for example, just a decade ago, the majority of students were attending a failing school. And by next year, we expect that not a single student in New Orleans will be attending a failing school. And Teach for America is very proud to have contributed to that change alongside many of our partners and community leaders. We have 20% of the teaching force in New Orleans is actually comprised of Teach for America core members and alumni, and we have 50 alumni school leaders working in the community there. So I think New Orleans is really poised to be a proof point for our country of exactly what's possible when you have leaders working together with the community to create change.
That's amazing. And one last question. With the key to Teach for America's success being its people, how are you using data to source the best candidates and hire the best applicants?
So Teach for America has always been a data-driven organization, but right now we're really excited to explore cutting-edge technologies like artificial intelligence to help us understand how we can better maximize the number of candidates who complete our admissions process, and also surface to recruiters individuals who are at risk of becoming disengaged with our organization or with our mission, so that we can recommend interventions to keep as many great people involved with Teach for America as possible and ultimately get more great teachers into classrooms.
Thank you, Jessica, for joining us here today. It is inspiring, truly inspiring to hear how Teach for America is strengthening the movement for educational equity.
Thank you.
We have one last interview here with Hire Heroes. Hire Heroes, a best-in-class veteran service organization empowering U.S. military members, veterans, and military spouses to succeed in the civilian workforce. I have Sean McDonald, who is partner of PwC Experience Center, who helped Hire Heroes with the project. And I'm also going to be speaking with Christopher Plump, Chief Operations Officer and Interim Chief Executive Officer, Hire Heroes USA. Christopher, let's start with you. Hire Heroes has a reputation of excellence. There's a lot of one-on-one involvement that occurs. What are the best practices that you follow that drives over 300 new clients per week to join your program?
Really, the key to it is the personalized service that we bring. You mentioned the one-on-one. Every veteran that comes in that needs help or spouse that needs help is entered into our Salesforce database and then assigned to a single transition specialist who's going to work them through their employment search up through the point at which they gain employment.
So you ran into some challenges. Like, that's a lot of volume. I can imagine that you want to make sure that the service is the same for everyone. What are the challenges you're encountering at Hire Heroes, and what's impacting your ability to grow and service more people?
The real challenge was the scale. Any veteran service organization that's taking in 300 clients a week is going to run into a problem of how do I service each one of them very well. With our high personal service, the challenge was how to keep it personal, but yet work to scale. In that regard, it was to have the transition specialist focused on the client and not focused on the data entry, and that's really where PwC came into play with us.
So Sean, let's switch over to you. PwC, you've been a long-time supporter of Hire Heroes. Talk to me about the level of support, the expertise that you brought to the table, and what kind of positive impact that's made.
Sure. So we brought a combination of strategists to really understand their business, because when Hire Heroes reached out to us, it was, we think technology can help, and we believe them. But in addition to that, we wanted to make sure it had the right experience. So we brought designers, both front end and through the workflow, and then the technologists on top of the Salesforce platform. The results have been really getting throughput through, as Christopher mentioned, demand of 300 a week. The way they used to solve that was they'd hire more people to support that demand. We said, we think, don't lose that human touch, but let's add in sort of an enablement and a productivity workflow with Salesforce.
Now, I know your partnership's going to continue for a long time. Christopher, in just a few seconds, I'll give you 30. I'm sure there are a lot of items on your wish list. We talked about a few earlier. Just imagine you could incorporate AI into a specific use case that would make the biggest impact on Hire Heroes in your programs, on all the veterans and military spouses. What would that be?
The biggest impact would be is we now have a lot of partners. We have over 450 companies that want to hire veterans. We have training organizations. We have education organizations, all that have specific programs for different people. What's really tough now is personally, manually trying to match the individuals in our database, which is now about 15,000 clients at any one time searching for a job, with all these opportunities that are available to them. AI could help us do that seamlessly and keep that personal touch to the individual as it's looking at the individual record and their desires and match them with the appropriate stuff.
Sean, it sounds like phase 2 is coming your way.
Can't wait.
Thank you both for being here, Sean, Christopher. Appreciate your time. With that, ladies and gentlemen, I would like to start the panel.
Ladies and gentlemen, please welcome Adam Lashinsky, Executive Editor, Fortune.
Thank you. Thank you for that warm welcome. My name is Adam Lashinsky. I'm with Fortune Magazine here in San Francisco. I'm going to bring on 3 panelists to discuss how AI will transform the future of business. The three panelists this afternoon are Richard Socher, the Chief Scientist of Salesforce, Suchi Saria, Assistant Professor at Johns Hopkins, and Peter Norvig, the Director of Research at Google. Please join me in welcoming them. Hello, thank you to the three of you for being here. I want to try to set the stage and set your expectations and your expectations. So you three are experts in one of the hottest fields in the scientific world and in the business world right now, artificial intelligence. I would suggest to you that this is a relatively scary and difficult concept and subject for everybody who isn't an expert in it. As a matter of fact, I think of the things that are going around in the business world right now, it's the second most complicated topic, the first being cryptocurrencies and bitcoins. It's the thing that people have the hardest time wrapping their heads around. So I want to spend the first part of our panel wrapping our heads around it. And Peter, I'll ask each of you, but Peter, I'll ask you to start by first the very simplest question, which is what is artificial intelligence? But more importantly, why are we talking about it? Why do we care, and why do we care now?
Okay. I guess I define artificial intelligence as software that does the right thing when you don't know what the right thing is. So regular software is I tell you what to do and you figure out how to do it. Balance the checkbook, there's a right or a wrong answer, all the numbers has to add up. AI is also software that you want to do the right thing, but the answers aren't definitive. It's like label all my pictures with the name of the people in them. Now here's a picture. It looks like that's Chris, but maybe it is and maybe it's not. There isn't a definitive answer. But AI still has to be able to come up with the right answer.
It almost sounds like you're like software is arithmetic and AI is what? What would the mathematical equivalent be if I'm asking the question correctly?
Yeah, so I think that's right, that traditionally we've thought of software as a mathematical science. And the foundations of software were in Boolean logic and in proof, right? So in the real world, we never exactly proved our programs, but we knew that theoretically we could, and maybe in college you proved a 5-line program, and you knew that that's what it was based on. I think AI is more of an empirical science rather than a mathematical science. So it's more like biology or physics, where you go out, you do experiments in the world, you don't know exactly what the truth is, and you try to figure it out. And so it's no longer based on Boolean logic, it's no longer based on certainty, rather it's based on probability and statistics and uncertainty, but making the best inferences you can.
Okay, that's a fascinating distinction, and I really appreciate that. Richard, I'll ask you to contribute to this, helping to demystify. The other problem we lay people have with artificial intelligence is that we hear a lot of different expressions. We hear artificial intelligence, we hear machine learning, we hear neural networks, we hear deep neural networks, and I'm probably leaving a few off. So take as much time as you like, but I should never say that to a professor, right? But help us out, please.
So I think we can distinguish between the types of techniques that we have and the application areas that we have. I think in terms of the application areas, it's very easy to understand what those are because we often look at human intelligence to define what we want to do in artificial intelligence. So humans have a lot of capabilities that are mostly originating in our brains. We have motor intelligence, which we don't consider often as intelligence, but we actually do pay people a lot of money if they can throw very small balls into very small holes very far away. And it's, you can make a good living with that. So motor intelligence is a big part. The second one is visual intelligence. It's a big part of our brain. It's just understanding visual inputs, and we've made a lot of progress on that compared to motor control, where in robotics we're still quite far behind humans. And then you have speech intelligence, just trying to understand words in our auditory cortex. And then one of the most interesting manifestations of human intelligence, I think, is natural language understanding. And so there we also still have a lot of work to do, but we're also making very good progress. Like machine translation on let's say, technical subjects is getting better and better and faster.
Let me ask you, let me pause you for a moment. Just come back to humans for a moment before we get to machines. When you talk about natural language comprehension, an example of that is that we humans understand nuance, right? And nuance is, I assume, for a machine, extremely complicated. Is that right? So it's not just what does the word red mean, but we understand the nuance of the color red, or I read the book, or I don't know.
That's right. Well, yeah. So there, some words sound the same, and that's different. But then there's a lot of complexity, and to fully understand language, it's almost AI complete. You need to understand visual inputs perfectly, social context perfectly. You need to almost have the feelings that we have in order to really understand what love means and all these other complex things. So
all of that so far is human intelligence.
That's right. And now in artificial intelligence, we have a lot of different techniques that we used to call statistical machine learning in the early 2000s. And then there's one set of algorithms that we largely describe as deep learning that are based on neural networks, which basically identified one major issue with all these statistical machine learning approaches and standard statistics. And that was that when you actually try to make something work, what the majority of the time was spent on was trying to describe your problem in terms of very simple features that then the AI was just weighting. So let me give you an example. In sentiment analysis, you could say, well, I can manually describe sentiment as positive and negative by saying, here are all my positive words and here are all my negative words. And then each word has a weight. So awesome has a very large positive weight, and really terrible has a very large negative weight. And you kind of sum them up. And then you realize, well, now we're making mistakes with negation. So then you come up with rules and say, well, if I see not one of those positive words, I'll say it's negative. And you keep adding kind of complexities and add additional features to it, and then hopefully in the end you get an accurate sentiment analysis algorithm. But you realize in the end there's so much subtlety, and it's really impossible to come up with all the rules of having negations. Like you could say, this movie doesn't care about cleverness, wit, or any other kind of intelligent humor. And now that is actually, despite all the positive words, a negative sentence. And so what deep learning did was to say, let's try to take as raw of an input as possible and still try to have a very accurate prediction. And so the raw input in image cases are just pixels, and in language case, they're just words. And we have a lot of supervised data, a lot of labeled data.
Supervised and labeled data, those are two terms of art. Explain what... Yeah.
That's right. They're the same, and they basically tell you the output of what you want to predict. And almost all the progress we've made in the last couple of years is based on supervised data, where you say, this is my English sentence, and this is the German translation. Do translation. Or this is my movie review, and that's a positive movie review or not. Or Suchi will have some very impactful applications in like medicine and so on, but there are a lot of simple, this is my input, this is the output. That's supervised machine learning.
Okay, now before I move on to Suchi, if human intelligence is a perfect 100, or I don't know, a platonic 100, where is machine intelligence today? Where might it be 30 years from now?
So I think right now, when you actually try to come up with all the complexities of human intelligence, we're very low. I'm not sure I want to put a number on it.
Why not? You're a mathematician, among other things, right?
Because what AI has so far only focused on is taking a single task, often a specific data set and a very concrete metric, and then maximizing that metric. And so we just do machine translation, but then you ask the machine translation algorithm about the sentiment, and it's just like, I don't know, German, like it's not gonna say positive or negative. It has only been trained on a single task. And there's very little, we're working on it, but there's still very little transfer between all these different tasks. When you can think about a motor task and then you can describe it in language, those kinds of multimodal interactions between different complex tasks, no algorithm can do
Okay, that doesn't sound very impressive to me, but I know that it's as impressive because we're spending all this time talking about it. So Suchi, maybe help us understand at a high level first what the impact of all of this is. And I'm teasing. Obviously, it's very impactful, or again, we wouldn't be here. But
so let me actually build on Rich's point a little bit. So one very simple way to think about AI and machine learning, statistical machine learning, deep neural nets, these classes of algorithms is, when you have a task, you first create an objective function, right? Like we're really good at when we played the game of AlphaGo. You've heard about that game when our AI won. essentially, when they were playing that game, there was a goal. That goal is often, win. Winning means, eventually you can do a sequence of things and you get a score. So once you have an objective, what we are effectively telling the machine to do is, building on what Peter said earlier, we can't tell you the strategy for winning, but we can tell you what your goal is. Your goal is to win. Now, if you know what the goal is, the next thing we tell it is, what are the sequence of moves you're allowed to do? So a sequence of moves in a game is the sequence of steps, valid steps or actions. If we were teaching the robot to say walk or do some mechanical task, then there would be an equivalent notion of a sequence of things it's allowed to do, like move its joints, right?
Excuse me, these are otherwise known as rules, right?
Well, but the interesting thing here is that these are not necessarily rules that says if A, then B, then do this. These are just the set of allowable possibilities. So it's saying, if you have 16 joints on your body, you can move them in continuous space however you want. Your goal is you have an objective in this 16-dimensional space in R16. You're trying to find the right configuration for the next move and the sequence of such moves in order to optimize your objective. So at the end of the day, it's a mathematical science in the sense that you're trying to figure out what is the sequence of such things, moves that allow you to optimize your objective. So now, tying back to what Richard said, the challenge in today's AI applications is that we've become incredibly good at taking hard tasks, finding the corresponding objectives, giving data and giving help to the algorithm to allow it to go from nothing or very little to it figuring out the sequence of moves to optimize that objective. But what we haven't become very good at is building an omniscient being that is good at everything. So essentially, what is the objective for being human? There isn't such a thing. There is a clear objective for learn how to walk without falling. There's a clear objective for learn how to pick up this cup. Well, I'm going to give you a cup, and I'll let you experiment with it till you want.
Yeah, okay, so that's super helpful. Now I'm starting to get it, because business isn't being good at everything or even achieving happiness. It's achieving certain goals. So
exactly.
Yeah, so let's be a little let's go from here to here now and be a little concrete. A few examples of how AI will, what do we called this transforming the future of business. I think solving a few problems would be sufficient, right?
Yeah, so I think, again, starting from where Peter started us off, which is historically we'd use software to solve problems where we knew how to solve the problem. And the job of the software was mostly to automate the sequence of rules we knew already how to encode. What's exciting about machine learning and AI is that in a large number of problems or scenarios where you don't know what is the right sequence of steps to get there, but you know what the desired outcome is, you can train a machine to teach you either how to get there or to automate a procedure for getting there.
Okay, now
So let me give you an example.
Yeah, great.
Let's say you wanted, relevant to Salesforce. So let's say you wanted to be able to make your customers happy. And they have complaints. And they're sending you complaints in like text documents or chat messages or whatever. It may or may not be super easy to create, you may want to hire someone to say, this is exactly how you take every chat message and respond. But maybe if you see a few experts responding to these chat messages over and over again in the right way, you could kind of now use algorithms to glean the essence of what is the right way to respond and the right way to triage these notes and the right level of urgency and the right ways to identify what the key issues are and the right way to know who the experienced person is who would know how to solve that problem. And these are all things pieces of software can now do. And now that suddenly rapidly accelerates the process by which we can tackle customer response. My area, I work in a lot of, one large area where my lab does a lot of work is in medicine. And there we see a ton of interesting and hard problems where, experts have practiced medicine in a certain way using knowledge that they've been taught in medical school and things that have come out of, this is, when you see this, do this. But as we're starting to accumulate more and more amounts of data, similarly, there's a tremendous opportunity to completely redefine diseases in areas where we know in a much more granular way the nuances of, the 10 kinds of diabetes or the, as we already know, more than 35 kinds of cancer, right? So anyway, so those are examples of where AI can easily help.
Richard, give us a concrete example of how AI is being used in business. Feel free to use your own if you like.
So I'll do the 3 simple things that we do at Salesforce a lot: sales, service, marketing. In sales, we have, for instance, lead and opportunity scoring, where based on all the conversations that 2 organizations have had back and forth over the years, or just last week, we can rank and say, today, these 10 people are most likely to actually respond positively to your email or your call. So lead and opportunity scoring, we have very clear metrics of if you actually focus on those, you will have a much higher conversion rate in your sales funnel. In service, we're releasing bots to deflect service cases. If you have simple questions, usually you have a power law in almost all the AI applications where you have certain things you see very often and you have a long tail of very rare events. You see this a lot in service, right? A lot of people ask, how do I log back into my account? Well, those kinds of questions, you see tons of different ways that people phrase them, and hence you'll also be able to automate those 80% of frequent questions with a bot. But there will always be people necessary to answer the kinds of questions of like, I have this version of Internet Explorer, and now you just upgraded this new thing, and now you need to, this button doesn't work anymore. And so you need to really, you've never seen that question before. People haven't, it's like that Internet Explorer version is from like 7.5 years ago. It's not clear why it's still around, and so on. So random example. And so you have this mix of people working with AI and AI taking away the simple stuff that you don't really need to spend that much time on. And in marketing, there are tons of exciting examples for AI. And I think actually new kinds of jobs will be created for people that understand that you can now go through millions of images and find all your company logos. Like somebody takes a picture of that new Adidas shoe and says, I love that thing. That's a great tweet that you want to...
That's your way of saying wrap up this. Was going on a bit too long. Kidding.
So in marketing, we can automate, we can understand the sentiment. We run a marketing campaign and then see if the sentiment about my brand on social media improved or not, and so on. We can segment people and group them to personalized marketing campaigns.
On your first example, I got to thinking, I feel like in customer service with technology, the pendulum swings, right? So once upon a time, you'd call up a merchant and say, I have a problem. And they'd say, I'll help. I'd like to help you with that. And then along came the time where we called and a computer at the merchant said, push 1 for this, push 2 for that, push 3 for this. And everybody hated it, but it saved the merchant a lot of money. And so they did it anyway. Right. And we kept hating it and we made the best of it. And you're saying, if I'm hearing you correctly, if this works, and what I can't tell is how far along the industry is, we may have the best of both worlds. That rather than that annoying voice saying push 7 for such and such, we'll sort of get to the right person more quickly.
Yeah, you just say what you want, why you're calling, and then either we can automatically answer the question right away, or we immediately get you to a person.
But where do any of you think we are today? Where I think we are, you're painting a very wonderful picture of the future, but I'm a consumer. I don't think we're anywhere near that right now.
We aren't. Complete natural language understanding is still pretty complicated, but we are making a lot of progress, and we can, for instance, identify very accurately, and this is a feature we're already rolling out, the intent. You write in a chat log what you care about, why you're chatting up a service representative, and immediately can identify the major intent. Is that a billing question, a service question, a sales question, and so on. So we're making progress, but it's still a lot of work to be done.
Peter, you talk about the invisible instances of AI, where AI is working in the background, and visible instances. Would you share that with everybody?
Yeah, I guess the first thing I wanted to say is that in order to deploy AI, the first step is really to have a mindset within the company that says data is valuable and we're going to collect it and do something with it. And once you're there, you can start with doing very simple things, the sort of arithmetic level stuff that you talked about, and then only later get to the fancier AI type things. So by invisible, I mean things where you're just making an improvement that nobody notices, right? So if I switch from the press 7 for this to I just going to know the answer to your question, then people say, wow, I really noticed that. That's a big difference. But if, the Google search results, the best things are a little, one link closer to the top, or the ads that you see are a little bit more relevant to you than they were yesterday, then it's not something that's noticeable. It's an increase to the customer, but they don't say, wow, there's AI behind that. They don't even notice subconsciously. It got a little bit better, and you can do continual improvement by keep doing testing. Every time you get a new idea, do this A/B test and say, yes, this one's a little bit better. It's not revolutionary, but you're ratcheting up and improving over time.
Okay, so that's the invisible. Yep.
This actually brings up a good point, which is I think you have a couple of these large consumer companies like Google and Facebook and Amazon that have multi-billion-dollar R&D budgets and really care about every last bit of the user experience, right? In maps, in search, in advertisement, and so on. And what I'm excited about at Salesforce is to actually try to bring some of that technology in a scalable fashion to all the other businesses that don't have these kinds of huge budgets to bring AI.
Well, you raised an interesting point, and Peter, you said something that I think resonates with a lot of business people, but also comes back to where I started, which scares business people. You said you need to have the mindset in your company that says we have a lot of data and we're going to use it. That's fine for Google, which has people like you and many other talented PhDs and researchers, but other than call up Richard and his colleagues, which is a perfectly good suggestion, I'm sure. But how does a business leader go from making the realization, I need to have this mindset, to getting this mindset? I mean, maybe there's a cement company out there. I'm sure they have a lot of data. What do they do? What do they do first?
I think it starts mostly top down, and I think that's true at Google as well. And you're certainly right that we're fortunate to be able to employ a lot of very talented PhDs, but we also employ a lot of technical people who didn't have any machine learning or AI skills. And we had a CEO who started going around saying, we're an AI company now. And boy, that really gets everybody's attention. If somebody says, I'm in a company and I don't know what that means, I guess I better find out. And so that top down, that sort of inspires people. And then bottom up, we provide the training. Right? So some of the people got that training in grad school, but for the rest of them, we have internal courses that says, hey, we're going to take you from zero to understanding what's going on. We're going to lead you step by step. Did
you personally need to go through a journey on this?
I did, yeah.
Tell everybody that. This isn't your original field, correct?
So I have been doing AI for a long time, but this newer stuff with neural nets is something that, when I was in grad school, it was the alternative. I remember Jeff Hinton coming to Berkeley and talking, and we all said, wow, that was cool. And we went back into the lab and implemented what he talked about and said, it doesn't quite work. Let's go back to the old way. And then, I guess around 2011 or so, it started working, and I said, I got to retool everything I know and try to forget the old way of working and understand this new approach.
And you two were part of the new wave, is that correct, in your graduate studies?
That's right. So I remember reading Peter's books in undergrad, and were one of my favorite books.
Actually, the AI class that we both took had Peter's book as sort of the main book.
Well, then I stand corrected, and I apologize for suggesting that you weren't present at the creation. Before we move on,
I was really hoping to discover something today about Peter.
Yeah?
That is, what did he do before he wrote this book? But I guess.
Peter, talk about I didn't give you a chance to finish the visible AI, the things that are apparent to customers, to users, to developers.
Right. So the visible part is when the user interface changes. When you go from clicking on a menu item to just speaking what you want, and the answer comes out immediately. And so everybody can notice that this is a different way of interacting. And in some cases, maybe even the back end behind it is the same, but the But the interface is different, and the AI has to be able to deal with that, and then everybody notices.
Richard, you and I discussed this when I interviewed you about a month ago. Peter referenced 2011 a moment ago, and I'm still trying to understand what changed. Why are we talking about AI today, and we weren't, I don't know, 10 years ago we weren't. You were, but we weren't.
That's right. I think there are three major technology changes that really enabled this new wave of AI. And those are the compute, data, and the algorithms. On the data sets, we now finally have enough capacity, but also workflows that collect more and more data. And every company that is currently not collecting data about their workflows and their processes should really start thinking about doing that. Whenever you have a service case, you should keep track of that email had this final answer to solve it, and various other things. You know, this chemical process, we put in these chemicals, this was the output, this worked, these were the properties, anything from agriculture to medicine to CRM. So the data sets are the number one thing, and they're finally big enough to teach algorithms that don't have to have all this human engineering inside of them, but they can learn from the raw data. But then those algorithms are very powerful, they have a lot of weights, and they take a lot of computation. And so there, we really have to thank NVIDIA and a couple of PhD students for realizing that what originated to just give you nice graphics and computer games and graphics cards was really part of that revolution, and that is having a lot of cores. Just to give you an idea, a very powerful GPU, graphics cards, originally just set up for gaming, has around 4,000 cores. And those 4,000 cores aren't as powerful as, you know, the 16 or so you have in a CPU, but the few things they can do are actually the exact thing you want to do for training large neural network-based algorithms. And so with that parallelization, we're able to train much more powerful models. And then on the algorithmic side, there were a couple of research breakthroughs in the last 10 years or so, and you can't quite pinpoint and say, that's the one research paper or that's the one breakthrough that made it all happen, but each breakthrough added maybe 2 to 6% accuracy, and then you go from something that is 60% accurate, which you just can't use in a business, somewhere where it's 90+% accurate, and now with the right workflow and fallback to humans, you can actually deploy in your business. And so those are the three things. They all created a perfect storm for AI.
Suchi, talk about, if you would, what your research is, specifically with regard to patient care, to give people a sense of how AI can, to use the hackneyed expression, make the world a better place.
Sure. So there's, I think, a variety of, just like Richard was talking about, what are key big changes that have happened that have enabled entire fields to change. So in medicine, one thing that's very exciting that's happened in the last 10 to 15 years is, in particular, the HITECH Act that happened in about in 2007, 2008, that led to hospitals and clinics being mandated to collect all their data. So now suddenly every time you visit the clinic, every time you visit a hospital, all of the data that's getting collected from them, making records of your notes, of tests, things you're measuring, anything they're ordering, etc. And what that really means is, we spend about $3.3 trillion in healthcare. Previously, we had no way of introspectively looking and seeing, how our healthcare system really operated. Now, suddenly, there's all this data to really go understand any micro piece of this process in great levels of detail. And so, let me give you some concrete examples. So, one example area is, something as practical as there are all these individuals who end up getting discharged from the hospital and end up coming back. And these are called frequent flyers. So the question is often, a large part of Medicare's bills are 5% of the patient population. And so the question is, who are these people? Why is it happening? Where are we screwing up? And in questions like this before, we had no way of trying to understand. Now that we can see their data in great levels of detail from every visit, tracking every single measurement that happened, when they came back, and sort of the notes of what happened, there's suddenly an opportunity to longitudinally analyze this population to understand differences. And so just, this kind of an approach and specific applications. So reducing 30-day readmissions, that's now almost there's a financial penalty for hospitals that have high 30-day readmissions. And so that's an area where large health systems are really, working hard to incorporate new machine learning or data-driven techniques to fix the way they're doing business. In my lab, what we do is invent new ways in which, so like an area we've made a lot of progress is, there are patients who come into the hospital, they'll have acute deterioration. So acute means something sudden happens that leads to rapid deterioration. And the challenge is many of these, if you had known and noticed it sooner, and you had gotten them the right treatment sooner, you could have prevented it. Or you could have prevented the downstream consequences of these deteriorations. So one big area where my lab's done work is this area of sepsis, which is the 10th leading cause of death. And
what is sepsis? Is it an infection?
Yeah, so it's an infection that goes awry, turns into a deathly event.
I see.
And the crazy thing is, it's preventable if you had known who are the individuals at risk and gotten them the right treatment sooner. And so sepsis is one such example. And here again, if we have all this data getting collected, it's the version of what Peter said. Humans don't know how to recognize it yet or recognize it early. But you can work with data to teach computers how to recognize these. And now it's exciting because you're basically providing a value add to these experts. And if you can figure out a way to get them to work together, the machine and the human, suddenly it becomes a more powerful system where you can figure out who are these individuals, get them the right thing, and do something to fix it.
And is that what you're working on? Are you focused on getting the humans and the machines to work together?
Yeah, my lab does 2/3 of my lab is focused on novel machine learning techniques in different, medical areas, and then a third on trying to think about how do we get humans and machines to work together to implement some of the actual algorithms we've developed in practice. Because there's still a big gap between us having a way to do something to being able to use it in a way that experts can be productive with it. Right? Just because it's possible doesn't mean that it's actually going to be productive.
Yep.
And that gap is actually, is going to require work.
Now you've hinted at what one of the big controversies around, for lay people at least, around artificial intelligence, which is that if we can teach the machines to do something well, we won't need the humans to do it at all. And I think sort of the most common medical application is that there seems to be this consensus that a machine should be able to read radiology reports either better or at least more of them faster than radiologists. So first, and I tackle that if you like, or more generally, but it seems to make sense. If the machine can detect tumors more efficiently than humans can, it doesn't sound like we need radiologists that much.
I think the problem in that statement is our understanding of what radiologists do.
Okay.
It's not the case that we type define doctors to be doing something really simple, which is, all they're doing is diagnosis. Diagnosis itself is a very complicated word. When you say, what is diagnosis? They have this disease, lupus. But that's a very small fraction of the job they're doing. They're trying to figure out which flavor of this disease you have, what is the next complication you're going to be, how to manage you. So in the same way with radiologists, your assumption is they're doing these cut and dry things where it's super straightforward. And I think that's the 80% tail example. And I think Richard actually has personal experience in this space, so maybe he wants to speak to it.
Yeah, so in radiology, we can identify a couple of the things that we see a lot of very, very accurately, but there's always going to be a long tail, and we don't have enough training data. There's currently no organization, which is actually quite sad. I think we could automate a lot of radiology more if every hospital was forced to de-anonymize their scans and give the final labels to some public database, and then the entire country would eventually have very, very cheap radiology services. There is currently no such thing, and because of that, it will take us many decades to capture more and more of all the things that could be wrong in a CT scan or an MRI scan and so on.
Peter, I'm gonna try with you. You know, these three are sort of obnoxiously in agreement with each other on the big picture. You're gonna get.
I was going to say I disagree with a few things that was said earlier, but I didn't know we were allowed to disagree.
Oh, you're completely allowed to. I think at this late in the day, everybody would appreciate it. So I'll ask you what they were in a moment, but I'll try to give you, Peter, a very easy to understand example that we're all thinking about a lot, which is if your colleagues at Google and other places are successful in developing quantum leaps in self-driving car technology, you know, it's going to produce all sorts of wonderful benefits for humankind, unless you happen to be a professional driver of a car or a truck. Mm-hmm. How will that be good for them, I guess is my question.
Yeah. So I guess first thing is think about it in terms of tasks rather than jobs. I think that's what what Sushi was getting at.
Tasks rather than jobs, yeah.
Right. And so right now, a truck driver has a job, and a big part of that task is driving the truck. Right. But there's other parts of the job too, of loading and unloading and supervising and making sure stuff doesn't get stolen and so on. And so it may be that part greatly increases, that the truck drivers now, coming into the warehouse and saying, here's the stuff, and saying, since I'm here and I understand how your warehouse works, let me tell you that my company has a capability to integrate your services into ours, and let me show you how it works. And that person right there can do that in a way that a salesperson over the phone can't, because they don't know how the warehouse works. It'll also probably be the case that if trucks get, if he's sleeping in the car most of the time while he's driving, now trucks get cheaper. And depending on exactly where the elasticity is, now there's more goods get sent by trucking. And so there's need for more drivers. Even as some of them get displaced, there's greater demand. So maybe one person is doing twice as much, but we require more people.
So somebody here help me understand something, because I confess my bias is with the three of you. I don't think you can find examples in human history of scientific advancements that haven't eventually led to more people doing more things. I mean, no one's sitting around complaining that people don't get to wash clothes over the rock in the stream anymore, right? I mean, that...
Or the bigger one is, 150 years ago, over 90% of all people worked in agriculture, worked in the fields.
Which was backbreaking and dangerous work and so on.
It was not fun. I don't think anybody misses it right now, but when tractors came around, there was some disruption in the labor force, and I think as a political system, it does make sense to think about what happens during those transition periods.
So is it the media's fault? I'm happy to blame the media because everybody likes to. Do these make for good headlines that the machines are taking over, the world is coming to an end? Is it that simple?
Certainly, stories about things coming to an end and the apocalypse and the Terminator are more interesting and probably get more readers. And things are going to be quite interesting, and we'll focus on more unique, creative tasks that are more fun. Very few people are going to click on that.
I think that. Right now, you're seeing less job disruption than you did in, say, the 40s through 60s when the farming industries were revolutionized with machinery. So the pace of change is actually slower right now. But I think people aren't so worried about what's happening today. They're saying what might happen in 10 or 20 years.
And are you concerned, Peter?
I think that the pace of change may be faster this time. So, in the long run, I agree with you that more wealth creates more opportunities and more demand, and there'll be new services to fill in the old. But I think, if you go to the case of farming, most of it was a case of, well, my parents and grandparents were farmers, but it looks like my kids are going to move off to the city and do something else. But with automation, it could be in a decade or two from now, I had a job for 2 years, and then that got automated, and I trained for something else, and I had that job for 1 year, and that got automated, and now I'm really, that's too fast for me. I can't take that anymore.
Yep.
And as a society, we're going to have to say we're probably going to need better education system, a lifelong education, rather than just I go to school, I get a piece of paper that says I never have to learn again. We're going to need continual upgrading of skills, and we're going to need more safety nets, because there may be periods when you're out of work and looking to get retrained.
So you've actually, I think you've framed it really well. I mean, we sort of know where we're going, but it's not at all clear how we get there or what happens in between. And let's face it, we're not very good at many of these policy decisions. So why should we assume?
It is kind of crazy. In theory, I think AI should be able to very cheaply and almost self-sufficiently give all the basic ingredients that people need to have almost for free. Like you could have solar-powered agricultural systems that basically automatically pick each lettuce leaf and various other kinds of things and do the harvesting and all of that, and can produce food very, very cheaply. We can, in the future, very easily, I think, build robots that build more housing and so on. So very basic human needs should be able to be fulfilled in an extremely cheap way, and then it's really up to the political system to make sure that everybody actually benefits from that.
Now, good luck with that. All right, let's end by addressing the ethical issues of artificial intelligence. Did you want to start? What interests you about the ethics of AI?
I think one thing that is, so I'm going to answer the ethics question, but I want to respond to something else. Like you asked Richard, what are some 3 things that changed that, and he mentioned data, compute, can't remember, what was the third thing? Algorithms. I think there's a 4th thing that's very critical here that happened that I never see bring up, but increasingly I feel is important, is the fact the industrialization of machine learning and AI. That means there was enough critical mass in industry where there were people in large numbers concentrating on specific problem areas, and they had a chance to really develop skills. And what that meant was suddenly it was much faster to get experience, right? If you're innovating in an area in a research lab, in academia, no matter how good you are, you're looking at a group of size 20 or 30 or 40. Suddenly, when you're at companies like, say, Google or Facebook, and lots of other companies, what became possible is to build big groups of such people where they were focusing on, and they could collaborate with academia and do things very fast and break things, and they had the mandate to break things and learn. Anyway, so I think that's important. So this also then ties into the ethics of things.
Before you say that, it's my reaction to that is it's an unsatisfying answer compared with, say, we now understand what happened when Moore's Law was invented. And what happened after that. That was like one of these aha moments. And we're still, I think, struggling to understand the aha moment, as interesting as those data points are.
So I think the aha is pretty simple here.
Simple for you, maybe. No,
it feels very simple.
Yes.
I don't know. I feel like it's never that hard. It feels very natural. All it is, we could play a little game. People can bring up a question of how do I automate this? What is the objective? You construct an objective. What kind of data? There are 10 ways to do supervision, or unsupervised, or side information. You develop a way to, you could get a group of AI experts together, and very quickly they could sort of narrow in on the strategy to take to get there. And then you need enough people with experience to implement and execute such a system. And I think all those ingredients started to come together. And that's really what's helped the field move forward very, very fast. So I don't want to dodge your ethical question about ethics, but I did want to add that point about, I think the industrialization has helped a lot in adding, in accelerating the pace at which we learn things. It ties to the ethics, though. So the ethics piece is, up until, I would say, 3 years ago, we were still kids with our toys. Nobody was monitoring us. Nobody was bugging us. We were coming up with new ideas. We're like, hey, this is a cool idea. Try that. Richard, try that. He's like, hey, this worked. This didn't work. And, that's kind of the way the field went. And, there were lots of interesting areas where we were deploying tools. And now, suddenly, it's in this new place where tools that we're developing and we're releasing open source, lots of other people are getting access to it, which is great. They're experimenting with it. They're putting it in their own world experience in new domains, which is great. But they're taking it very seriously sometimes in ways that they shouldn't.
What's
so
an
an example
Yeah.
would be, looking at an image and trying to predict whether you're going to be a criminal or not. Right? That's not like if you actually go down and understand the science of what that is saying, it doesn't make any sense. But just because you could, take a large database and train something in that database to, you annotated that database to provide some supervision, it's basically just mimicking what it has already seen. It's not actually like a causal, it's not doing any kind of causal inference to say what is the mechanism that makes you a criminal or anything like that. All it is doing is mimicking or replicating behavior. So where's this going? So the point of this is that, there are these tools that are freely available. There's engineering expertise or expertise available to use these tools. These tools are becoming easier to use in new domains, but the education of what is a valid or invalid use of this tool is drastically lagging, which means we suddenly see lots of interesting new applications, and every so often we see applications that aren't right, or they're incorrect, they're biased, they have consequences.
Yeah.
But there's no one to police it because nobody came, we are used to talking to each other and figuring out what is the right thing to do and being told when something doesn't make any sense. But now the industry is kind of in an uncontrolled way downloading these tools, and then, there are press articles being written and there's no one to police. So anyway.
Just so everyone's clear, literally Suchi and Richard we're graduate students together, and you're part of this. When you say we in the field, you're a relatively cohesive group of people because it wasn't a large field until it's getting larger now. It still isn't a large field, right?
That's right. It used to be the NIPS, which is one of the top conferences, Neural Information Processing Systems, was a pretty small conference. Now just one of the workshops in that conference is bigger than the whole conference used to be just 8 years ago. So it's a very large field. And as we're touching more and more people's lives with these AI algorithms, we do need to very carefully think about how they're impacting people's lives, right? They can change elections for the worse. They can spread misinformation in some benign natural language processing classification algorithms, right? You want to maximize numbers of clicks. Well, something that has a Terminator or something will get more clicks, so you put more Terminator pictures in articles.
Pick up on Suchi's comment about bias, if you would.
Yeah. That is one of the biggest ethical issues that I think we have right now. All our AI algorithms are only as good as the training data that we give it. And so if your training data has certain biases against genders or age or sexual orientation or whatever it is, it will get picked up. So if, for instance, you're a bank and you want to build a loan application classifier, whether you want to grant a loan to a new founder of a business or not, and it turns out that in the past so far only 5% of all your loan applications that you've approved had female founders, your algorithm will pick up and say it's bad to be a female founder, we should not give that person a loan in the future, and that's clearly not the right thing to do. It just happens to be the past of your data set, which people may have also had biases. So biases have existed, humans have them. Now that humans have created those data sets, algorithms will have them and potentially amplify them and make them even worse. So there is a lot of research that is now getting started. There's a great class at Berkeley, and folks at Google are looking into this too, of how can we get rid of bias on the algorithmic side. But really, you have to, on your data set side, really carefully think about that. And just to give a concrete example, in our group, we had a side project, and the people basically wanted to build an emotion classification algorithm.
An emotion classification
So
algorithm.
a picture of a person comes in and you say, are they happy, angry, sad, surprised, grumpy, whatever it is. And immediately, which I don't usually say often, is we cannot ship this until we look at all protected classes and make sure that old people aren't always classified as grumpy, because it turns out we only had 2 pictures of old people when they were happy, because we had a lot of stock pictures and they always showed middle-aged, good-looking white people.
Right.
And we need to be very careful whenever these algorithms touch human lives, and really just have some empathy in some ways with how those are going to be deployed, and then carefully think about what training data we give it.
Peter?
So I guess I go back to this idea that we're basing AI on collecting data, and that means we have to be good shepherds of that data. So we have to realize, to the extent that data comes from customers, that we have a contract with them to take care of it and not use it in the wrong way and not let it get hacked and so on. And that's not necessarily AI, but it goes along with it. I think there's a requirement for transparency. You have to explain exactly what it is you're doing and how you're doing it. And I think you want to always have AI embedded in a larger process from which there's escape. So essentially, you should always be able to hit zero and get to an operator. The AI shouldn't be the final link in
a human operator.
Yeah. Or it could be you get transferred to another system, and then at the end of that, you get to an operator. So it doesn't have to be immediately, but at some point, you have to say, we built these systems that are good at doing things they've seen before, but are not necessarily good at novel things. And every now and then, there's going to be something novel. And to claim that the system can handle that is just hubris. That doesn't make any sense. So the system's got to be designed to get around that. And then there's this field called AI safety. And to me, that really shouldn't be a separate field, right? So we don't have like engineering safety.
Right.
We don't have
medical safety.
I'm building safety. Bridges. Yeah. Oh, and this guy is in charge of building bridges that don't fall down, but that's a separate field. Right? So we need that to be embedded everywhere to say right from the start, you have to say what could go wrong. And of course, software always has bugs, and we've been dealing with tools to eliminate those bugs for the 50 years or so that software has been a big industry. And so AI has two tasks to measure up. One is it's got to use all the best practices that exist from software engineering, and sometimes it doesn't because it's driven by researchers who are more academic and don't know all that history. And then secondly, we got to come up with a new tool set that says, what's different about AI programs compared to normal software engineering, and what additional types of debugging tools do we need?
So I think this is the perfect place to end. I think no one in the room would doubt that AI is going to transform business, and I think that everybody in the room understands at least a little better how. And so I want to ask each of the three of you to take just about a minute to give some advice, one parting piece of advice to the room, to business leaders. What's one thing they should do to spend the next 12 months coming up to speed, getting their arms around this topic, whether it's something to read, somebody to talk to, or actually some exercise they should go through in their business?
So the thing that I really love doing side projects. So what I would do is take the time to, go on Coursera. There's lots of material online to take, or Udacity. Take a little online course on this, and lots of these courses will talk about, technique A and technique B and technique C and math, lots of equations on how to get there, but really kind of follow the course for what is the general high level view, and then try to see around you, what do you think is an aspect of your life or the work you're doing where you could see an opportunity for bringing in these ideas and doing a little side project, And I think that'll be very exciting because you'll get to see, where the opportunities lie and be creative with it.
And I think the takeaway is that most business leaders are not going to design AIs at any point in their career, but the time has come to understand the concepts.
Right, and to be imagining, to be creative with it.
Yeah, Richard, one piece of advice.
Never think of AI in isolation. AI is always AI plus X. You're applying AI to a specific skill or to your business. And if you think about what your X is, in most cases, getting to that AI plus X starts with your training data. And so whenever you have any work process, think about how to collect the outputs of that process. What creates unique data set that will eventually allow you to have some competitive mode to your competitors, and then make sure that you hire some data scientists into your organization, because even if you use outside vendors, they need to talk to somebody, they need to get data from you somehow, some pre-processed format, ideally in one location, in order to help you out. So even when you have outside vendors, have a data science team, start thinking about collecting your data and all your workflows.
Peter?
I agree with the idea that data is an important asset. And I guess advice would be to talk to your employees and ask them, what's your pain point? either for you doing your job or for the customers that you work with? And what would it be like if that was automated away? And then figure out if that's possible.
Suchi, Richard, and Peter, thank you for a very stimulating conversation, and thank you to all of you for listening so carefully late in the afternoon. Thank you.
Thank you. Thank you.